Very good evening, all of you. As we wait for all of you to join, as a brief summary, I will be just writing down some of the notes which is already given to you. As I said, the concept, the video on the concept of dot product is already given to you. You can go through that. I hope you've gone through it. And if you haven't, after this class, please go through it without fail. But this will be a brief summary of what was done in that previous video in the concept of scalar product of two vectors. So I'll not be discussing much on the concepts, but as we wait for more of you to join, I'll just give you a brief summary of what we're being studied. Orthogonal means perpendicular. The two vectors are perpendicular, so that means theta would be equal to pi by 2. A very good evening to all of you. Many of you are joining in, so it's good. It's a very good sign again. Day by day, our family gets bigger. So it's good to see that all of you remember. Please do remember that all these videos that have been created are actually for you only, so that learning, education doesn't remain stagnant. So as I've always said, we will need your support. I continuously say that every video, that I would like to thank each and every one of you for your constant cooperation, because your constant cooperation when we make videos, you like, you subscribe, it's a constant motivation for all of us, for us to see that students actually are learning. And when you share, it might just help another person who is in need of a source to learn mathematics, especially during this pandemic. Of course, there are many more topics being discussed in the previous videos also, but these are just some of the basic terms which we will be definitely using a lot. There are some more again, but those, I guess, as we proceed with the solution of the exercises, all that will be revised. And as I have already mentioned, the videos are already uploaded for you. Kindly check it out. Salam. A very good evening to all of you. It's nice to see all of you joining. Alright then, so without wasting much time to get back to business. So, welcome each and every one of you back again to your channel of Learning Mathematics. Yesterday we finished exercise 10.2 solution, so today we are going to be we will finish exercise 10.3, that is based on scalar product of vectors, which is also known as dot product of vectors. Now these two topics, dot product of vectors and vector cross product or cross product of vectors, are going to be very beneficial for you even in physics also, when you talk of magnetism, electric field, and also this will be again helpful for you in your physics. Okay, so please learn this chapter properly. It's a small chapter, a very simple chapter, but a very conceptual and a basic chapter, very important for higher studies also. All right, okay then, so let us begin with exercise 10.3. So a lot of revision also will be done. So chalo, you can take out your books, get ready. Exercise 10.3. Come on, let's begin. Exercise 10.3. Alright, the question is, find the angle between the two vectors a and b with magnitude given √3 and 2 respectively, and having their dot product to be √6. So I'm not going to be writing the question again. 10.3, I believe all of you have your textbooks with you. Question number 1, the magnitude of vector a, magnitude of vector b, that's given to us. That is, magnitude of a is √3 and magnitude of b is, and the dot product is given to be √6. So it's a simple question. So you can just write down angle between the two vectors. Angle between the two vectors, that would be, we can write theta equal to directly cos inverse of, as I've just given you the formula. If not, then when you come to the classes, please bring your notes also, so that your formulas will be in front of you, so that you can easily see how each topic should be done. So I'm just going to proceed here. So that's going to be cos inverse a dot b, this product already given to us. So this is just like a revision question only, nothing much for us to do. This is 2 into √3. So cos inverse √6, we can write it as √2 into √3 divided by 2 into √3. So that would be cos inverse √2 by 2. Now cos inverse class 12 standard, so I think I can just do it directly. √2 by 2 is 1 by √2 by rationalizing. So theta equal to cos inverse cos pi by 4, because 1 by √2 is cos 45, so cos inverse pi by 4. So the angle between the two vectors in simply pi by 4, that is 45 degrees. This was something like a practice question for us. Alright, so let's get ready for the next question again. Those who are finished, you can get yourself ready with the next question. Number 2. Alright, so yeah, yesterday we could reach the half century for number of likes. Today also, let us try. Thank you so much again, but chalo. But it would feel much better actually if all of you can hit half century in your exams also. That would be much better actually. At least half century, chalo na. So if all of you can achieve this half century of marks in your examinations, at least, I mean, if you go for century, wow, that's really good. But if you at least go for half century, then I would really feel that my hard work has really paid off. Our hard work, not mine, our hard work has really paid off. So I'm keeping my fingers crossed. I know you are not going to let me down. Alright, anyway, moving on to the next question, that is question number 2. Again, same question, find the angle between the vectors, but this time the vectors are given, so we have to solve. Anyway, no problem. Let's find out a dot b first. So I minus 2j plus 3k into 3I minus, we have to find out the angle, okay? 3k, you know the formula, isn't it? I gave you. So go for the dot product. Now if you remember dot product, it's very simple. Orthonormal vectors also I've already given it to you. No, I, j, j, k, k. 1 for dot product. I, j, j, k, k, I, k, j, all those will be 0. So when you go for the product, it's very simple. All you have to do is, listen, look at it carefully. Just multiply the I, j, j and k, k. Bas. Forget about the rest. Alright, just multiply I, j, j, k, k. Only that. Alright, what I mean is, of course, use brackets properly. So coefficients only. I1, isn't it? So 1 into the other coefficient of I, 3. Go for positive signs only so that you can see these simple topics, no? Very easy to lose marks because of carelessness. Please don't do that, okay? Plus this one, minus 2 into minus 2. Plus 3 into 3. Got my point? I've discussed that in the previous video also. So just I coefficients, j, j, k, k. Just multiply the coefficients. In the beginning, just add, use proper brackets. After that, you can remove the brackets and all. 3 plus 4 plus 9. So 9, 10, 11, 12, 16. So the dot product of A into B, A and B, I mean, is 16. Three I minus 2j. You can make a small correction actually with the textbook as per the textbook answer. But anyway, let's just give it a try. After that, we will get to know. But I think it's going to be impossible to find out because in the I'm actually referring to the old textbook. So it's in the other textbook. It is this value is k, not 3k. Okay, you can just check whether it is correct with your textbook also or not. Kindly check once. And try to do that. Try to get the product again. In the meantime, I'll just confirm once. Just give me a moment. I'll just confirm. I minus 2j plus 3k, 3I minus 2j plus k. Yeah, that's fine. I mean, the correction has to be done. So you can just kindly correct that. So this should be key as per the textbook solution. So 3 into 1. So that will be 3 ones are 3. 10. So please make that correction in the in your textbook. If corrections is to be made, some textbooks there might not be any corrections to be made. It might be as it is. All right, let's go. That would be magnitude of the vector. We have already done yesterday. 1 square 1. I'm going to do it directly. Plus minus 2 square 4 plus 3 square 9. So 9, 10, 11, 12, 13, 14. And magnitude of B. Magnitude of B would be 3 square 9 plus minus 2 square 4 plus 1, that is also 14. So let's get the angle then, angle between the two vectors. So you can just write on like let theta be the angle between the two vectors. So theta would be cos inverse of A dot B divided by magnitude of A into magnitude of B. So that would be cos inverse of 10 divided by root over of 14 into root over of 14. So that would be cos inverse of 10 by 14. So that would be cos inverse of 5 by 7. Alright, and that's actually the textbook answer. So I hope you have made the necessary corrections. हो गया? चलो, let's move on to number 3. This is about projection. Find the projection of the vector on the vector. So let's at least name the vector. As I've always said, please do name your vectors. I, J. And the vector B, what is it? I plus J. So directly, simple questions. As I say, this chapter is simple. Projection of what? A on B. Find the vector, projection of the vector this on the vector this. So the projection of vector A on B. So what was the formula for projection of vector A on B? B. The formula was A into B divided by magnitude of B, or vector A into unit vector of vector B. Good evening. So let's find out. So that I'll just do it here. I minus J, I plus J divided by magnitude of B, root over of 1 plus 1. So again, dot product, this is dot product. So just multiply the coefficients, 1 into 1 plus minus 1 into 1 divided by root over of 2. And this one, of course, there's no discussion also. 1 minus 1 divided by root over of 2. Yes. So the projection of A on B is 0. Okay? Alright, done? Shall we? Question number 4, I'm going to leave that to you because that's the same question like this one only. Projection only. So question number 4, I'll leave that to you so that we can save some precious time also. I don't want to keep you waiting for more than 1 hour because it gets really boring, isn't it, after 1 hour. So the question number 4 is same, that is find the projection of the vector on the vector. So it's going to be the same, use the same formula. Bas. Okay, let's go to 5. Show that each of the 3 vectors is a unit vector. That's the first job. This is vector A. Okay, let me just find out the magnitude because our job is to show that the given vectors are what? Unit vectors. Also show that they are mutually perpendicular to each other. This is going to be a lengthy question, so let's do it quickly. Second part we will do later on. Let's do the first part first. So let's go for the magnitude. That's going to be root over of, I'm going to do it directly, 2 by 7 square. 2 2s are 4, big question. So 9 by 49 plus 36 by 49. So this is 36, 40, 49. Common LCM 49 by 49. Root over of 1 and 10. So the magnitude of vector A is 1. Good evening all of you. Magnitude of vector A is 1. Similarly, B. The first job is done, no? To prove that the given 3 vectors are unit vectors. I'm going to write down that B now directly. That is 3 by 7i. I hope you can catch up. If not, please let me know in the comment section below. I will write everything in detail, but I think it is fine for all of you. So its magnitude would be 9 by 49 plus 36 by 49 plus 4 by 49. Those who have been regularly attending, you will know, and those who are watching afterwards also, I guess you will know how these are calculated. First timers only, you might be slightly confused, so for that, of course, you can just go back and watch the videos after this. So there also the magnitude is 1. Next, for vector C. So let's do that quickly. Vector C, 6 by 7I plus 2 by 7J minus 3 by 7K. So its magnitude also should be 1 because we have to prove that it's a unit vector. 6 square 36, 49, 4, 49, 3 3s are 9, 49, 36, 40, 49. Yes. So this also the magnitude is 1. So hence proof. First part proof. So conclusion, you can just write down, that is like thus. Each of the 3 given vectors is a unit vector. Thus, each of the 3 given vectors is a unit vector. Okay? Okay? Alright. Second part of the question. What is the second part of the question? Second part of the question is says, show that now they are mutually perpendicular to each other. Mutually perpendicular to each other. So let's, one by one, let's go for the product. A dot B. Remember, mutually perpendicular, what happens? As I had given to you, the dot product should be what? 0. Because mutually perpendicular means the angle between the two vectors should be 0. I mean 90 degrees. So cos 90 degrees is 0. So that's why the dot product is 0. So that's one way to check. So that will be 2 by 7I plus 3 by 7J plus 6 by 7K unit vector dot 3 by 7 minus 6 by 7 plus 2 by 7. Let's go for the dot product. 2 by 7 into 3 by 7 plus 3 by 7 into minus 6 by 7 plus 6 by 7 into 2 by 7. So this is 6 by 49 plus minus 18 by 49 plus 12 by 49. So taking common LCM, 49. 6 minus 18 plus 12. So 12 plus 8, 6, 18 minus 18, of course, 0. So here, which implies that A is perpendicular to vector B. Since A dot B is 0, we can say that they are mutually perpendicular. So A and B are perpendicular to each other. As I've mentioned, always in vectors and all, always try to maintain one particular rotation. So if you start with A, B, don't change again. Of course, for dot product, it will not matter much, but it's better to follow, you know, this route. So A, B, so A into B, done. Got it? So A into B is done, solved. So similarly, I'm not going to do it. Similarly, okay, you will do that. So you can, if you're writing it down, you can leave some space in your copy and you can do that later on. Then you will realize how much you have learned. So next what you will do is B dot C you will find out. Okay, B dot C. That also you should be getting 0. And then A, B, B, C. Next, C dot A should also be 0. So that will prove that they are mutually perpendicular to each other. Alright? I guess you can do that, isn't it? No problem? Okay. Alright, let's go to the next question. Number 6. Find the magnitude of vector A and vector B if vector A plus vector B into dot product or into 8. Also given magnitude of vector A is 8 times of the magnitude of vector B. So you have already seen associative property, commutative property of vector multiplication and also we are just going to be applying. So normally for, especially for dot product, really doesn't matter because dot product scale, that's why it's called scalar product of two vectors. Result is a scalar, so direction will not be affected. Okay, so of course we're going to learn something. So if we just multiply, we're going to learn a lot of new things here. Not new things, revise actually. So that's going to be A dot B plus multiplying these two now. B dot A minus B dot B is equal to 8. That's simple multiplication for you. Now this is something which I have already discussed in the previous video also, that A dot, so scalar. But the correct way of writing, writing also matters, isn't it? How we write mathematically, technically correct. So this will be square of the magnitude of vector A, which is also same as A square. If you remember, yesterday while doing vertices of a right angle triangle, we talked about this. So this one I can write it as square of the magnitude of vector A, and this value for dot product, remember associative, commutative properties and all. For dot product, for vector cross product it's not true, but for dot product A dot B and B dot A will be same because result will be a scalar only, whereas for vector cross product result is going to be a vector, so there even direction also should matter. But here A dot B, B dot A are same. So now you can see that it is A dot B, B dot A are same, one is plus, one is minus, so they can cancel out each other, so you will be just left with square of this. Now vector A square is actually 8 of magnitude of B whole square minus B square is equal to 8. That's 64. B square minus magnitude of B square is equal to 8. Okay? Okay, so 64 minus 1, that's 63, magnitude of square of 8, so B square would be 8 by 63. So what will be the value of the magnitude? Magnitude means positive quantity, no? So that would be 8 by 63. So that can be written as 2 root 2. 63 is 63, 3, 21, 3, 7. So that can be written as 3 root of 7. Alright, so that will be the magnitude of B. So what would be magnitude of A? It's given in the question 8 times the magnitude of B. So 8 into 2 root 2 by 3 root of 7. So that will be 16 root of 2 by 3 root of 7. Alright. Okay, done? Chalo. Next question. Alright, we are at the half-hour mark. Time to drink some water, refresh ourselves. So if you have your cup of water, glass of water, kindly have that. Let's get back to, in the meantime, you can write down the other question. That's the next question. Evaluate the product. A simple question based on that previous question only, just product only, so just multiplying, and we know A dot B, B dot A, they are same for dot product. So 21 minus 10 plus 11, 35, done. Simple question, okay? Sir, you are always saying all the questions are simple. Of course, if you practice and you maintain your regularity in practicing mathematics, if you practice regularly, surely, maths is easy. It's all about the concept, the concept of 8. Find the magnitude of the two vectors A and B having the same magnitude. They have the same magnitude and such that the angle between them is 60 degree. The angle between them is 60 degree. And their scalar product means dot product. Scalar product is 1 by 2. So these are the informations given. You're supposed to find out the magnitude of the two vectors. And it's said that the magnitude of the two vectors are actually same. So let's try to solve this using this condition. Simple question. So A dot B will be magnitude of A into magnitude of B into cos 60 degree because theta is 1. Nah? That's equal to 1 by 2. Their magnitudes are same. So you can just consider any one of them. So I'll just consider B also as A. Cos 60 is kitna hai? Cos 60 root of 3 by 2. That's equal to 1 by 2. No, cos 60 is 1 by 2. Not root 3 by 2. No. So that's going to be A square is equal to 2 cancel 1. So magnitude of A is 1, and since the magnitude of A and B are same, so the magnitude of A and B is 1. See, such a simple question. Nothing much to be discussed over here, over this question. Yeah, chalo, let's do 9. Find x, the magnitude of the vector x. If for a unit vector, you have to read the question properly and try to get all the information that you can get from the question. Okay? So find magnitude of x if for a unit vector, that means the vector A is a unit vector, so its magnitude will be 1, such that, similar question only, x minus a into x plus a is 12. Actually, we can use it directly also, because this one, if you multiply, we have already seen that this will be square minus a square is equal to 12. This is also formula only, or if you just multiply, we have seen, we get this. Okay, so we can use it directly also. So this is square minus this is 1, so 1 square is equal to 12. So x square magnitude 12 plus 1, that will be 13. So magnitude of the vector x would be root over of 13. Another job done. Another one bites the dust. And another one bites the dust. Number 10. Question number 10. Okay, na? Alright. Question number 10. Chalo. Question number 10 is the given vectors are given. Given vectors are given. Good evening, all of you. Given vectors are given. Vector A is given. 2i plus 2j plus 3k. Vector B is given. Minus I plus 2j plus k. C also given. 3i plus j. So if the vectors A, B and C are given are such that A plus lambda B given A plus lambda into B is perpendicular to vector C. You know what happens when vectors are perpendicular, isn't it? Right, you know what happens when the vectors are perpendicular. So we'll get back to this question. But before that, we will need the value of, okay, so let me just complete. So in that case, a plus lambda into b and dot product of vector c should be how much? 0. So with the help of that, what are we supposed to do? Find the value of lambda. Now maybe we can just solve this separately, okay? So I'm going to just use this condition here. So that's going to be a plus lambda b would be equal to a plus lambda into b. Got it? So finish this one, I'm rubbing it off, okay? So this one, if we just add the respective coefficients, 2, this one, lambda, should I write or, okay, let me just write. First one, okay, just for this question. After that, later on, I'll just start writing directly. Lambda into I plus 2 lambda into j plus lambda into k. So if we just add the like terms, 2 minus lambda into I plus 2 plus 2 lambda into j plus 3 plus lambda into k. So now using equation 1, the dot product of this vector 2 plus lambda I, 2 plus 2 lambda j, 3 plus lambda k into the dot product of again c. What was vector c for us? Vector c was 3i plus j. 3i plus j. This is supposed to be 0. So again, just multiply the respective coefficients of the unit vectors. That will do. So 2 minus lambda into 3, right? Plus 2 lambda into 1 plus, okay, I'll just write 3 plus lambda. For k vector, here we don't have k unit vector, so that's going to be 0, equal to 0. So 3 2s are 6 minus 3 lambda plus 2 lambda is equal to 0. So 6, 7, 8 minus lambda is equal to 0. So lambda equal to minus 8, minus cancel. Directly I am writing, so that is going to be 8. Thank you, Binjong. Thank you for that motivation. I really appreciate that, because once in a while, of course, I do get a lot of. There are times when, forget about the negative part. Let's not talk of the negative part, but time and again, just to get this motivating words, time and again, as I have always said before, really helps us, because what we are just trying to do is just trying to help out the student community, because. There will be, I know that there will be many who are just no online classes. There will be many problems. Let's not talk of the problems. So we're just trying to help out the community, student community, by teaching what we know, sharing, because education is all about sharing, learning is all about sharing. What's the whole point of keeping it for yourself? So time and again, when we get this, this encouraging words to someone just pops up out of nowhere and then says, keep up the good work, you're doing a good job, I'm learning. This really motivates us. As I was telling you yesterday, sometimes even we get tired, just to come up and then, stand and then just continuously make videos. Sometimes we get tired, but when we see that the students are motivated, they are encouraged in learning, we are not tired. We are not tired anymore after hearing all those beautiful words. And as I'm saying, we really need this motivation, because you and I, we have to hold our hands together, and then for your own benefit, because it's all about learning for your cause. So yes, do kindly keep on bringing those motivating words. I will keep on producing more knowledgeable videos for you, and one day definitely we will live to share this story. Okay? Alright, get back to business now. Enough of the talk. Got it? Okay, let's move on to the next question. So how many questions done today? Number 10. Okay, number 10 done. So we are almost there. Number 11. Show that this vector vector plus b into a is perpendicular to this vector ab minus b into a. So we have to get the dot product as 0, because to get the perpendicular we have to get the dot product as to be 0 for any two non-zero vectors a and b. So no problem, let's multiply and see. Okay, so chalo. See, questions like this, never go for the looks, okay? As I have always said again, sir, you always talk about what you say, but never judge anyone. Always, my dear children, do remember that, okay? Never judge anyone without knowing them. As the saying goes, never judge a book by its cover. Okay, we have crossed the half century for the number of likes. Congratulations. Wow, everybody. So, but as I was saying, like never, judge anyone on another person's perspective. Okay, we should know that person, because that person might just not like another person, and then he might just come and tell you that this person is not good. You should never, judge a person without actually knowing that person. You always. So that same saying goes on the questions also. That's life, practically life, applicable everywhere. Never judge a question just by looking at it, because some questions look so deadly. You solve them, very simple, like this. Let's go for the dot product. Just multiply. So this will be minus, because this will be this will be this. Let's start with this. Of course, this is not 0. We have to prove that it is 0. Now you can see that these two values are actually same. AB magnitude, AB, BA. I mean AB, BA, plus, minus, gone. Zero. But that's what I was telling you, don't judge just by looking at the question. Questions are very simple. Of course, it's dot product. For vector product, these things would not hold. It would be very different. But dot product, not a big problem. Aram se. Ho gaya. All right then. Let's move on to the next question. Finished, huh? Okay, next question 12. Conceptual question, that is, if A dot A is 0, alright, A dot B is also 0. Then, question is what? Then the question is, what can be concluded? What can be concluded about the vector B? What can be concluded about the vector B? How can we say? So of course this implies that this square is 0, so that implies magnitude of A is also 0. This also will imply that A, B cos theta is also 0. So, what are we doing? Okay, maybe the mosquito is also trying to learn mathematics with us. So we are even motivating the mosquitoes also. Okay, from where did that come here in this room? Okay, chalo. Learn. Alright, so what can be concluded? See, A A dot A is 0, so that's very clear that vector A is actually, the magnitude of vector A is actually what? 0, so there's no doubt about that. So most probably vector A is a 0 vector. Yeah, vector A is not a 0 vector, but its magnitude is 0. A dot B is 0. So with this knowledge, what can we conclude about the vector B? Yes? Magnitude of A is actually 0. Isn't it? That's what we get. So this is 0. But does it mean that B also will be 0? No, because you see, A dot A is 0, so that means magnitude of A is 0. Fine. So, and A dot B is also 0. So that means since this is already 0, so the outcome of course will be 0. But that doesn't imply anything about vector B, isn't it? We just cannot say that vector B is also a 0 vector. Absolutely not. Because vector A is already, magnitude is already 0. So that's why the whole term also, this dot product is also 0. But we cannot bring out any conclusion for vector B, isn't it here? We cannot just simply say that vector B is 0. That's not possible. So what can be our conclusion? Because after that we don't have any other knowledge information. So what can we basically conclude? That vector B is maybe either a 0, yeah, is either a 0 vector, or a non-zero perpendicular vector. Perpendicular, because the dot product is 0, so definitely A and B of course has to be perpendicular. Or in just other words, simple words, like you can just say like B can be like any vector. Of course, yes, maybe not perpendicular also actually. B can be actually like any vector, to be honest. Because since vector A magnitude is 0, so even though they are not, yeah, of course, since the condition is about perpendicular, but since this is 0, I don't think we can really say that B is also perpendicular, because this is already 0 vector, and magnitude is 0. So this would be the appropriate answer, that is like B can be like any vector. So what can we say about vector B? Nothing much. We can't say anything much. Why is this mosquito disturbing me? So we can't say anything much about vector B. So I think the best answer that we can have here is vector B can be any vector. Not much information provided to us about vector B. Okay, just a conceptual question there. Okay, 13. Are you all there? I guess all of you are there. Chalo, 13 about to be over. Okay, chalo. A, B, C are unit vectors. As I said, always read the question properly. So A, B, C are unit vectors. So that means magnitude of A is equal to magnitude of B is equal to magnitude of C is equal to 1. Unit vectors. Alright, it's been a long time I haven't asked. How are you, all of you? In the meantime, let me just have a glass of water. How are you doing, all of you? I haven't asked that for quite a long time. I hope all of you are doing well. Time to do some chit chat. How are you doing, all of you? Oh yeah, today also no response. Come on, give me some response. How are you doing, all of you, my dear children? Okay, Lee, it's Lee. Okay, right there. Saying good. Yes, sir, doing fine. Good to know that. Who else is doing fine again? Okay, Sinat doing great. Perfectly fine. Alright, I'm doing great. Wow, so many positive news. By the grace of God, fine, doing fine. Wow. Fresh as a lemon. Alright, cool. Even at this hour, you're still fresh as a lemon. Oh, hats off. I'm almost about to be now battery. About to be. For me, of course, battery is almost done. But anyway, since I'm with you, definitely my battery is still charged again. Chungalier, alright, good to know that. Okay, so I hope you have had your thumb exercises. Now, some more are doing good again. Okay, Tako Jongla is also doing good. Imsadullah is also doing good. So good to see so many positive and good news. Alright, let's go back to the exercise 13. If A, B, C are unit vectors such that vector A plus vector B plus vector C is a zero vector. The addition of these three vectors is a zero vector. Then the question is, find the value of A dot B plus B dot C plus C dot A. You remember a formula for A plus B plus C whole square, algebra class 9. That was, remember this one, A plus B plus C whole square. It was A square plus B square plus C square plus twice of AB plus twice of BC plus twice of AC. Now if you look at that, all of a sudden they're just given this and then they want you to find find the value of A dot B, B dot C, C dot A. Maybe somewhat related to that. So we will give it a try. We will try to square both sides. Okay, we will try to square both sides. So then in that case we will have A, because these three vectors are zero vectors. So even if we square the value, it will remain the same. Because that's what it means. Now A plus B plus C is a zero vector. So you multiply it again, zero vector only. 0 into 0 is how much? 0. Alright, doing good, good to see that. Chalo. Now let's multiply. Let's multiply and write down the values directly now. A dot A, directly, A square, plus, okay, A dot B plus A dot C plus B dot A plus B dot B, that's B square, plus B dot C plus C dot A, I'm continue here, plus C dot B plus C dot C, C square is equal to 0, vector into 0 vector, 0. So, if you just group them, A square plus B square plus C square plus A dot B, 2 times of A dot B, because we know that for dot product it's all the same. B dot C plus twice of C dot A is 0. So this is 1, this is 1, this is 1 plus 2 times. So now you can see what they want in the question slowly getting into shape. So 1 plus 1, 3. I'll move that to the other side. Minus 3, so the value that the question needs for us to find, minus 3 by 2, bus. Minus 3 by 2. A simple question again. Okay, almost done. So time to move on to 14. Another conceptual question there. If either vector A, or these are zero vectors, not that their magnitudes are 0. Okay, these are zero vectors, and of course magnitude will be 0. Yeah, zero vector magnitude always will be 0. So we talk of zero vectors, definitely their magnitude is also 0. So if the magnitude of a vector is 0, there definitely the vector is a zero vector only. Yeah, that's also true. Because when you go for the magnitude, we only add, isn't that? Square plus square plus square. So definitely there's no sign of subtraction. So definitely if the magnitude of a vector is 0, then that vector is, of course, yes, as discussed in the definition, zero vector only. And then A dot B is also 0. So if either A or B is a zero vector, then they say that A dot B is 0. Fine, that is understood. But the converse need not be true. Converse means, you got the question, justify your answer with an example. Justify your answer with an example. Now, did you get the question here? What the question is telling you is, if either A or B is a zero vector, then their dot product, of course, will be zero. But the converse need not be true means, but it doesn't mean that to get the product of A dot B as zero, it necessarily does not have to mean that these two vectors are zero vectors. Yes, if A and B, either of them are zero, their dot product of course will be zero. But it is not necessary that both the vectors A and B should be zero vectors to get the product zero. We have already seen that for perpendicular vectors also. They can be any two vectors, their product can give us the result zero. So it's not necessary that only the product of either of the vectors being a zero vector or both only will give us the value zero. No. How to prove that? Let's just take some example. Let vector A, let's just take one example, be equal to like 2i plus 3j plus 6k, and the vector B. Not just any random example, okay, we have to think. 2k. Now you can see that A and B are definitely not zero vectors. Let's go for the dot product and see what do we get. 2 into 3, 6, plus 3 into 6 minus 18, plus 6 2s are 12. So 12 plus 6 minus 18, 0. Now you can clearly see that the converse need not be true. Because here it's clear that vector A is not a zero vector, vector B is also not a zero vector, but their dot product definitely can be zero again. What the question was telling us was, no, A and B only when they are zero, then only we can have A dot B as zero. Not necessary. There can be other vectors also. Their product can still give us zero. So we can just write on the conclusion, hence the converse need not be true. Hence the converse need not be true. Okay, 15. If the vectors ABC of a triangle ABC, vertices are this respectively, then find angle ABC. Is given that angle ABC is the angle between vectors BA and BC. So that means we will have to find out BA. What was BA? BA would be position vector of OA minus OB. We're going to write directly now. So what was OA? A vector, we're going to write directly. So 1, 2, 3. So I plus 2j plus 3k minus, what is B vector? Minus I plus 0 plus 0. So bus, only that. And we need to find BC vector also. OC minus OB. So what is OC vector? 0, 1, 2. So 0i plus 1j plus 2k. Yesterday we have already done this, and B vector is minus I. So this is j plus 2k plus I. So if we just arrange I plus j plus 2k. Fine. Done? So to find out the angle, we will need its magnitude also, isn't it? So let's try to get the magnitude. Done? I'm going to do it here. So I'm going to find the magnitude of vector BA here. We will root of 2 square 4 plus 4 plus 9, this one. So 9, 10, 11, 12, 13, 17. And BC 1 plus 1 plus 4. So 4, 5, 6. So angle theta. Okay, we can just write down let theta equal to angle ABC. So we know that cos theta is equal to, as per the given condition, it would be BA dot BC, BA magnitude BC. Alright, okay, unfortunately I rubbed off vector BA. BC I have it here, I plus j plus 2k. BA, this one I have 17, BC I have 16. Can anybody quickly just tell me what is BA vector? Which we already calculated, unfortunately I just rubbed it off. Just correct me if I'm wrong. And if I'm correct, please someone tell me it's correct. Looking at this, let me just try. 2i, 2j, 3k. Did I get it correct? Vector BA? Alright, thank you. 2i plus 2j plus 3k. Alright, so let's continue then. So this is cos theta equal to 2 ones are 2 plus, this is all positive signs, so I'm just going to do that. 2 ones are 2 plus 2 threes are 6 divided by 6 sevens are 42, 102. 6, 7, 8, 9, 10 by root over 102. So theta equal to cos inverse of 10 upon root over of 102. Yeah, thank you for your quick response. Yeah. Zalo, 16, quickly, almost done. Show that the points are collinear. So let's write down directly OA. Position vectors, as I've always said, point vertices are given, write down the position vectors. Got it done. OB, 2i plus 6j plus 3k, and OC. 3i plus 10j minus. Okay, I guess all of you are getting tired. I'm also very exhausted. It's almost 1 hour cross. Anyway, just be with me. Almost there. Almost there. So this is number 16. Show that the given points are collinear. So let's just find out the values of AB, BC, CA. Always try to follow that rotation. A, B, B, C, C, A. Okay, A, B, B, C, C, A. Or you can go for AC also, no problem. Okay, let's just try to find out AC. So AB, as we know, OB minus OA. BC, OC minus OB. AC, OC minus OA. So this will be how much? OB minus OA, 2 minus 1. I, 6 minus 2 plus 4j, 3 minus 7 minus 4k. This one, C minus B, 3 minus 1. 4 minus 4. C minus A, 3 minus 1, 2, 2. 10 minus 2, 8. Minus 1, minus 7, minus 8. We just have to prove that it's collinear. It's not given that you have to follow this method, you have to follow that method. Nothing is method. We just have to follow that it's collinear. Remember yesterday, I gave you if condition for collinearity or parallel, especially parallel lines, then vector A should be equal to lambda times of B. or vector B equal to lambda times of A, then we say that the vectors are parallel. Right? Can you see some resemblance here? Because this one, if I take 2 common, I'll have I plus, we are just trying to do the easiest method, okay? So that is like 2 times of maybe AB vector, AB, AC. I'll choose AB and AC. So see, this is 2 times of AB vector, isn't it? So that means one thing is sure, that these 2 lines, 2 vectors actually are what? Parallel. So AB vector and AC vector are, of course, one thing is sure, parallel. Collinear means they can be parallel also, no? Lying on the same line. But we have to prove that they are collinear, not parallel, isn't it? We're not supposed to prove that they are parallel. We're supposed to prove that they are collinear, lying on the same line. No problem, because you see, one condition is proved that they are already parallel. But you can see that there is a common point. But A is a common point. So there are 2 conditions supporting our answer here. First is that the 2 vectors are parallel, definitely. Second is that, like, A is a common point. So I cannot have A, B and AC. In that case, these 2 lines are not parallel. Absolutely not. So they have a common point and they are parallel also. So most probably it's like just an example, A, B, AC, I guess. So, but that just verifies that the 2 vectors are collinear. So, but A is a common point. So, A, B, C are collinear. I think this explanation should do, isn't it? Because first thing that it's that they are parallel, no problem with that. A, B and AC are parallel. On the other hand, A is a common point. So how can you have 3 points where one is a common point and then at the same time they are parallel? See, I cannot have this, no? In that case, they are not parallel, isn't it? Yeah. And A is a common point, so yeah, since A is a common point, so definitely A, B, C are collinear. There are other ways to prove also. Okay, if you're not satisfied with this, then there are other ways to prove. You can, as we have done in lower classes, you can just prove that one side is equal to the addition of the 2 sides. So you can also prove like this, AB. So if you can just prove that one of the side is equal to sum of the other 2 sides, AC is equal to AB plus BC, then also we can say that they are collinear because they are having a common point only. Here B is a common point. Alright, so there are many ways to prove that they are collinear. Okay? Not only one way. So if you don't like this one, you can try the other one which I gave you. Alright? Okay, Babri. 17. Show that the vectors these and these form the vertices of a right angled triangle. I am not going to do this one because if you remember yesterday we did the same question on this. You can use the same concept. It's the same. Nothing is exactly the same, my dear children. So it's going to be same. I'm sure you will be able to do that. So check yesterday's video or the notes that you have completed, exactly the same. Alright, so you can do that. Last question, last. Oh, finally, come on. I hope all of you are there with me. Okay, 18. If A is a non-zero vector of magnitude A and lambda is a non-zero scalar, then lambda into vector A is a unit vector if, multiple choice question. So, lambda into vector A is a unit vector if what? Lambda into A, their magnitude is what? 1. Isn't it? So as per the question, then lambda is a unit vector if, so the condition is there, so that is like lambda into A equal to 1. So magnitude of lambda into A is already given in the question that A is a non-zero vector of magnitude A. So that means A would be 1 by magnitude of the lambda. Simple. So the option number D. Finish. So that's the end of the exercise for 10.3. So I thank each and every one of you again for being so patient in learning. I really truly appreciate that. Please do continue to give me the same support. Okay, my dear children, thank you so much. So that's the end of today's session. Tomorrow we'll come up with the vector cross product. Okay, vector product of two vectors or the cross product of two vectors. All right, so kindly go through the video of the vector concept on vector product and come prepared. All right, so thank you so much once again. It's good to see so many of you are turning up positively and regularly. I really truly appreciate that. All right, so have a good night, all of you, and those who are watching it now. So have a good night, all of you, and I'll see you very soon tomorrow. All right, so bye bye, take care.